Bismillah Rahman Rahim. I'm Sarah Khan, your instructor for the course titled Application of Statistics in Psychology with course code 509. This is our 20th lecture. In the previous lecture, I introduced the Pearson correlation as a technique for describing and measuring the linear relationship between the two variables. Whenever two variables are correlated, we can predict one variable from the other variable. And the technique which is used for the prediction of one variable from the other variable is known as regression or the regression analysis. Or the regression analysis actually provide us the technique or the statistical procedure which by following that technique or the process we can predict one variable with the other with the help of the other variable or the variables. So in this lecture we will talk about the straight line relationship, and this straight line relationship will be used for the prediction, and for the prediction we use the regression analysis, and regression analysis is based on least square method for finding the regression line, and by following the least square method of finding the regression line, we will discuss about the regression equation rather than the straight line, and then we compute the regression. So these contents will be discussed in today's lecture. At the last, we will compute the regression equation and put the values of the x variable, and find and predict from the value of the x variable the y variable, the dependent variable. Correlation. Pearson correlation measures the degree to which the set of data points form a straight line relationship. And if the strength of the relationship is strong, we can predict one variable from the other variable. अगर वेरिएबल कोरिलेटेड नहीं है तो फिर ये प्रेडिक्शन वाला काम नहीं किया जा सकता. हम फिर एक वेरिएबल से दूसरे वेरिएबल को प्रेडिक्ट नहीं कर सकते. प्रेडिक्शन के लिए वेरिएबल्स का कोरिलेटेड होना बहुत ज़रूरी है. Okay. This figure represents the hypothetical data showing the relationship between SAT, scholastic aptitude test scores, and the college grade point average, जिसे हम GPA भी कहते हैं. Note that the figure shows a good but not perfect positive relationship. Also note that we have drawn a line through the middle of the data points, and this line serves several purposes. First of all, the line makes the relationship between the SAT and the GPA easier to see. हमें सिर्फ देखकर ही पता चल जाता है कि क्या रिलेशनशिप है, पॉजिटिव रिलेशनशिप है या रिलेशनशिप वीक है या स्ट्रॉन्ग है. ये हमें बहुत आसानी से हम देखने से ही इसको जज कर लेते हैं. सेकंड, द लाइन identifies the center or the central tendency of the relationship. The line indicates the center, just as the mean describes the central tendency for the set of scores. Thus, the line provides a simplified description of relationship. For example, if data points were removed, the straight line would still give a general picture of the relationship between set and the GPA. Third, the line can be used for prediction. So finally, the line can be used for the prediction. This line establish a precise one-to-one relationship between x and y. And for example, in L and set score of 620 corresponds to the GPA 3.5. Thus, a college admission officer could use the straight line relationship to predict that the students entering college with a SAT score of 620 should achieve a college GPA of approximately 3.25 or 3. Yes, it corresponds to the 3.25. Sorry. So our now in this way, this line can be used for the production. Our goal is to develop a procedure that identifies and defines the straight line that provides the best fit for any specific set of data. This straight line does not have to be drawn on the graph. It can be presented in a simple equation. Thus, our goal is to find the equation for this straight line that best describes the relationship between x and the y. And regression, which is a statistical technique for finding the best fitting straight line for the set of data, is called regression, and the resulting straight line is called the regression line. So the regression is a statistical procedure that determines an equation for the straight line that best fits a specific set of data. And the regression analysis is a way of predicting an outcome variable or the dependent variable from one predictor variable, which will be the simple regression, or from several predictor variables, which will be the multiple regression. Because this straight line is extremely useful for describing the relationship between the two variables. So this the regression, which provides us the standardized method for determining the best fitting straight line, is very useful for finding the best fitting straight line. The goal of the regression is to find the best fitting straight line for a set of data, and to accomplish this goal, it is first necessary to define precisely what is meant by best fit. For any particular set of data, it is possible to draw lots of different straight lines that all appear to pass through the center of the data point. जैसे कि इस में हम कई लाइनें लगा सकते हैं जो कि तकरीबन डाटा के सेंटर में से गुजरती होंगी. Each of these lines can be defined by a linear equation of the form y is equal to bx plus a, where b and a are constant that determines the slope and y-intercept of the line respectively. Each individual line has its own unique values for B and A. The problem is to find the specific line that provides the best fit to the actual data points. जब भी हम कोई लाइन लगाते हैं जो कि बिल्कुल सेंटर ऑफ द डेटा में होती है, उन हर लाइन की जो बी और ए की वैल्यू है जो कि कांस्टेंट है, ये डिफरेंट होती है। अब हम डेटा को रिप्रेजेंट करने के लिए उसकी सेंट्रल टेंडेंसी को देखते हुए हम लाइंस तो लगा लेते हैं, 2 लगा ली, 3 लगा ली या 4 लगा ली, जिसकी हर लाइन की बी और ए की वैल्यू डिफरेंट होती है, लेकिन हमें ये नहीं पता चलता, ये पता लगाना बहुत मुश्किल है कि कौन सी लाइन जो है वो बेस्ट फिट है टू द एक्चुअल डेटा पॉइंट्स। ये मसला जो है वो इसका सॉल्यूशन किया गया लीस्ट स्क्वायर सॉल्यूशन से। टोटल स्क्वायर्ड error is equal to y minus y hat square. Now we can define the best fitting line as the one that has the smallest total squared error. Now, for obvious reason, the resulting line is commonly called least square error solution. In symbol, we are looking for the linear equation of the form y is equal to y hat or cap is equal to bx plus a. So this is the equation of finding which define the straight line, best define the straight line, and we calculate the value for b and a with the information taken from the sample, and calculate the predicted value of y for a set of data. B and A are as follows. B is equal to SP. SP is the sum of products, and divided it by SSX. सम ऑफ प्रोडक्ट्स हम पहले भी निकाल चुके हैं, पहले भी कैलकुलेट कर चुके हैं। अब नेक्स्ट जो है एग्जाम्पल में भी हम कैलकुलेट करेंगे। ये एक्स हम सबसे पहले मीन लेंगे, मीन डेविएशन मालूम करेंगे, और एक्स की मीन डेविएशन और वाई की मीन डेविएशन को जब हम मल्टीप्लाई कर देते हैं आपस में, तो वो सम ऑफ प्रोडक्ट्स के इक्वल होती है। इसी तरह से जब हम एक्स की जो मीन डेविएशन है उसका हम स्क्वायर करते हैं तो एस एस एक्स होता है, और जब हम वाई की जो मीन डेविएशन है उसको स्क्वायर करते हैं तो वो एस एस वाई की इक्वल होती है। तो हमने जब बी की वैल्यू मालूम करनी है तो बी जो है वो किसकी इक्वल है, एस पी ओवर एस एस एक्स, वेयर एस पी इज द सम ऑफ प्रोडक्ट्स एंड एस एस एक्स इज द सम ऑफ स्क्वायर फॉर द एक्स कोर्स। हम इसे एक और तरीके से भी कैलकुलेट कर सकते हैं। कॉमनली यूज्ड अल्टरनेटिव of the formula for the slope is based on the standard deviation of x and y, and the alternative formula is b is equal to r into standard deviation of y divided by standard deviation of x, where sy is the standard deviation of y and x or the standard deviation x is the standard deviation of the x course, and r is the Pearson correlation for x and y. So after calculating the value of b, uh, we will calculate the value of a, which is equal to mean of y minus b, which we have been calculated, uh, b into mean of x. Note that these formulas determine the linear equation uh, that provides the best prediction of y values. This equation is called the regression equation for y. The regression equation for y is the linear equation y hat is equal to bx plus a. This equation results in the least square error between the data points and the line. This is a set of data from which we calculate the regression line. Uh, First of all, we take the mean of x, which is 4. Summation x is equal to 32, and n is equal to 8. When we divide the 32 by 8, we get the value of 7. So we will subtract this mean from each value of x. 5 minus 4, 1 minus 4, 4 minus 4, 7 minus 4, and 6 minus 4, 4 minus 4, 3 minus 4, and 2 minus 4. We reach equation 5, 1, 4, 7, 6, 4, 3. Okay. In the same way, we will calculate the mean deviation of y variable. First of all, we will measure the mean of the y variable. The total of the y variable is 56. When we divide 56 by 8, it gives us the value of 7. So we will subtract 7 from the each value of y. 10 minus 7 and 4 minus 7 and 5 minus 7 and 11 minus 7, 15 minus 7, 6 minus 7, 5 minus 7, and 0 minus 7. Okay. 1, 3 minus 3 and equal to 0, 3 and is equal to 2 is equal to 0 and is equal to minus 1 and is equal to minus. In the same way, is equal to 3 is equal to minus 3 is equal to minus 2 is equal to 4 is 8 is equal to minus 1 is equal to minus 2 and is equal to minus 7. Okay, we store these values. 1 is 1, 3, 9, 0, 9, 4, 0, 1 and 4. The same way we will square the mean deviation of y to get the sum of square of y. 9, 9, 0, sorry, 4, 16 and 64, 0, 1. I will recheck it, which is आपस में एक सब हो रही है, इसको recheck कर लेंगे. 4 and 14. 9, 9, 4, 16, 64, 1, 4 and 14. Okay. Now we will multiply this value with this value. 3, 9, 0, 12, 16, 0, 2 plus 2 and recheck here. 3 minus 3 and minus 3 9, 2 0, 4 into 3 12, 8 into 2 is 16, 1 sorry 0 1 with 0 is equal to 0, minus 2 and minus 1 is equal to 2 and minus 7 multiplied by minus 2 is equal to 14. Add these all values, we add these values to get SSX, and we add these all values to get SSY, and add these values to get SP, sum of products. Okay. Use the calculator. 1 plus 9 plus 9 plus 4 plus 1 and plus 15 is equal to 28. In the same way, we will add all the values of squared mean deviation of y, the y scores. 9 plus 9 plus 4 plus 16 plus 64 plus 1 plus 4 plus 40 is equal to 156. 156. Okay, again we will add all these values to get SP or the sum of products. 3 plus 9 plus 0 plus 12 plus 16 plus 2 and plus 14 is equal to 56. 56. Now we will calculate standard deviation of x variable. We will put the value in this formula. 28 divided by n 2, 3, 4, 5, 6, 7, 8. So you can calculate here the 18. So n minus 1 will be equal to 7. And we have to take the SS S X is equal to divide the 28 and divided by 7 is equal to 4, and we take the square root of 2 and 4 is equal to 2. So the standard deviation of x is equal to 2. Now we will put the SSY value in this equation. 156 divided by 7 and we will draw the line. इसको थोड़ा एहतियात से लगाना पड़ता है. So when we divide the 156 divided by 7 equal to this value, and take the square root of this, and this is equal to 4.72. 4.72 plus y equal to 4.7. Now we will calculate the value of B, and highlight these values that we need. Next, now we put the values of SP and SS in this formula. SP is 56 and divided by SSX, which is 28, which will be equal to 56 divided by 28, which is equal to 2. B is equal to now we will calculate the value of we can calculate the value of P with the other formula which I already mentioned. B is equal to R into S standard deviation of Y divided by standard deviation of X. So first we will calculate the value of R, then we will calculate this value. R is equal to SP divided by SS X into SS Y and its under root. Or okay, the value for SP is equal to 56 and divided by S28 into 156. And root or is equal to 56 divided by 28 into 156, and taking the square root of this value equal to 66.09. 66.09, and when we divide this value, (56 divided by 66.09). Is equal to 0.85, 0.847, 0.85, 0.85. This is the value of R for the correlation. We will put these values in this formula. 0.85 into SY is 156 divided by 2. The standard deviation of Y. Standard deviation of Y is 4.72. 4.72, which is divided by standard deviation of X, which is 2. And it will be equal to 4.72 is divided by 2, and this 2 is 2.36 is multiplied by 0.85, which is equal to 2.006. It's mean 2. So it is equal to 2. तो जो हमने इस फार्मूले से बी कैलकुलेट किया उसका आंसर भी 2 ही आया है, और जो हमने दूसरे फार्मूले से बी की कैलकुलेशन की है वो भी 2 ही आया है. नाउ वी विल कैलकुलेट द वैल्यू ऑफ ए. We will put these values in this equation. Mean of y is equal to 7 minus b is 2, and into mean of x which is equal to 4. So 7 minus 8 equal to -1. All the calculations have been completed. So regression line को कंप्यूट करेंगे. These two x की वैल्यू कोई भी हो सकती है, वो भी हम पुट करके देखते हैं. x and plus -1. So the equation is equal to 2 x minus 1. By putting the value of x in this equation, each value of x, we can predict the value of y. Uh, value of x is by putting the value of x 5, x is equal to 5. So y is equal to 2 into x5 and minus 1. 10 minus 1 is equal to 9. In this way, we can calculate the y variable, predicted y variable, from by putting the each value of x in this equation. The regression equation should not be used to make the predictions of x values that fall outside the range of values covered by the original data of the regression equation was calculated as the best fitting line within the range of the original data. जो भी हमने जो भी x की वैल्यू पुट करनी है इसमें इस इक्वेशन के अंदर, वो जो हमारा सेट ऑफ डेटा जिसके लिए ये बेस्ट फिटिंग लाइन जो है वो कैलकुलेट की गई है, उसी ओरिजिनल डाटा के बियॉन्ड किसी एक्स वैल्यू को पुट करके हम उसके लिए वाई की प्रेडिक्शन नहीं कर सकते, बिकॉज वी हैव नो इंफॉर्मेशन अबाउट एक्स वाई रिलेशनशिप आउटसाइड दिस रेंज. The equation should not be used to predict y for any x values lower than 1 or greater than 15. ये जो हमारा डेटा था इसके अंदर जो लोएस्ट वैल्यू जो है वो 1 या 0 है और हाईएस्ट वैल्यू जो है वो 15 है. तो हम या x की वैल्यू को अगर हम कंसिडर करते हैं, क्योंकि हमने x की वैल्यू को जो है कैलकुलेट करना है, 1 is the lowest and 7 is the highest. So 1 and 7. So the equation should not be used to predict y for any x value greater than 1 or greater than 7. This is activity for you, x and y variables, and have to find the linear regression equation for predicting y from x and predict y for each value of x using the regression equation. यानी आप 1, 2, 3, 4, 5, 6 predictions करेंगे y की from these x values. So today we learned a step ahead from correlation. Correlation only tells us about the relationship or the strength of the relationship. If the two variables that are highly correlated, we can predict one variable from the other variable, and this prediction can be done by using the regression analysis of regression and the regression equation. Actually, regression is a statistical technique which use a straight line, best fitting straight line for the set of the data. uh, and predict the y variable from the uh, x variable. And this best fitting line is not drawn graphically on the paper. This best fitting line gives us our equation from which uh, two are the constant b and a, and we can calculate the value of a and by putting the value of x in the equation. If we have the values of b and a, we can easily calculate the predicted y for each uh, value of x. So this is activity for you, and you have to calculate from each x value the predicted y. And this can be only possible when you uh, linear when you find the linear regression equation for predicting y from x. So these are the references you can consult if you find any difficulty. Any question or any query will be handled in the class, inshallah. So Allah Hafiz.